I'm Brock Marks, and this is ShakyBot 2, the competition robot that I brought to navigate to a course to find a cone. As the screen shows, I had 3 basic goals in mind. I wanted to be cheap, less than $100. I wanted to be small, so you could move it around, you know, so we could take it up here every night, you know, on Tuesday nights and work on it. And I wanted to ultimately find the goal. So, hardware that you need obviously a cell phone for this. You need Arduino Uno. You need a Bluetooth module to be able to communicate from here to the Uno. You need a RC car, and I kind of didn't, I left this out, but you also kind of need a way to sense how far away the cone is once you get to it. So you can use ultrasonic sensors. There's probably other ways like LiDAR, you know. So what my logical process was is I bought a toy car. I got with these guys and they showed me how to find which pins activate the motors based on sending a high 5 volts to the H bridges on the board itself. So I'm using the actual board that's built into it in order to activate the motors. And I do that via the Uno. So once I was able to do that, then the next goal was to get communication from a cell phone through a Bluetooth module to the Arduino. So the first thing you want to kind of do is just get like a hello world going. You want to be able to turn a light on and off. So I got on the internet, there was a bunch of research. You know, I found a website that showed you how to do that, and I just incorporated that. The most important step to that was I had to figure out what key to use, because there's a key on there that you know, stuck on it for a couple of days, and then I realized there's a specific key for each one of these Bluetooth modules. And then once you find the key, you just plug that in, and it worked.
So the key is like an address then?
Yeah, it's kind of like an IP address except for Bluetooth, and it also has like a pin, to a 4-digit pin. These generally have like a default pin of 1, 2, 3, 4. And then the next goal was to, I would say, getting GPS data. GPS data on the front. Because the reason why you want to go with a cell phone bot is mainly because there's a GPS built into this thing, there's a compass built into this thing, there's cameras already built into this thing, there's accelerometers, gyroscope, so you don't have to wire up a lot of stuff. You just need to be able to communicate from this to the Bluetooth in order to do some pretty advanced things. So you get on the sort of the development websites, and you find little code chunks through Android that will tell you exactly how to access GPS data and start bringing it in. Once you start bringing that in, then you can, you know, put it on the screen via text, right? And then you can visually see. That's the other cool thing about a cell phone is you can visually, you know, see what kind of data you're getting, and it's easier to troubleshoot than if you just had a GPS module and you know, a computer. So you could actually go out and you know, test it in the field.
So do you have, sorry to interrupt, but do you have code that puts you on the map, kind of like a Google map sort of thing, or?
I don't in particular.
Okay.
I was going to do that, I just never got around to it. I'm just getting raw data, and I know based on that raw data what my latitude and longitude is. And I store one point, and then I can walk, and I have a little Android has a little function built into it that you can access that will give you the distance you traveled.
Okay.
and you can kind of test it that way and make sure it's all working. And then, so, let me all right, so the software you need, if you go to this website right here, it kind of builds, it has a development kit built for you, pretty much. It has the basic things you need. You're going to need Eclipse, you're going to need the Android development kit plugin, and you're going to need OpenCV for this project. And this has all that plus more built into that website.
What's the website?
It's right here.
Yeah, my eyes aren't that good.
Sorry, it's https://developer.nvidia.com/tegra-android-development-pack. Let me see if I can blow that up.
Are you gonna send that out on the list?
Yeah, just mail that.
Yeah, we'll mail it to the list, guys don't have to worry about it.
Oh, okay, yeah.
Actually, when we put up the YouTube video, we'll make this into a PDF and attach it to the website for this presentation to the YouTube video.
You might find it by Google too. I think I remember seeing the NVIDIA
Yeah.
site, whatever, Tegra, Android
Yeah,
stuff.
the Tegra development pack's pretty popular.
Right, so, yeah, this is an Android phone. I mean, I'm sure you can do it with Windows and everything else. It's just, this one has a lot of stuff, this particular package has a lot of stuff built into it that you need for a robot. Okay, so the basic algorithm is you get your point. You can either get the point by plugging it into my program and then saving it, or you can just go down to the point and save it. I have a little button that saves the point, and then you go back and you put it into the little holster I 3D printed for this. And then as it goes down the road, it stays in this configuration, because one of the things I found out through testing, just through, realizing that certain things were not going to work. If you have it up like this the whole time, the compass gets off because of the wheels. The wheels have this thing where when you're going around corners or anything like that, it throws the compass reading way off. And so you really, phones are designed when you're using the compass to be like this. So that's the reason why I have it down while it's going to the point. And then once it gets within 5 meters, it flips up and then it accesses the camera and the OpenCV software to look for orange, right? And it looks for an orange blob of a certain amount. I did a little test and find out how much that amount was. Because if you go with too small amount, any little bit of orange will set it off and it'll go off in the wrong direction. So you need to have a blob big enough that you can see that as a cone, but if it's too small, then it could go off in a wrong direction. And then, of course, the sensor, once you get within a certain amount of distance, tell it to stop. I'll pass this around if you want.
Brock, what happens if the camera flips up? The camera flips up and you don't see an orange blob. What does it do?
Okay, so if it doesn't see an orange blob, what it's going to do is it's going to go in a circle, a slow circle, and then go out. It's going to be like a spiral out.
Okay, so it turns a slow circle and a small circle. And
Right, and then once it finds orange, then it's going to because the camera on that front camera
Mhm.
was a little offset, it's not going to be perfect on. What it's going to do is it's going to try to center that as much as it can. And if it goes off the camera, then it's going to back up a little bit and try it again. That's why it was doing this number in the video until it finally got to the point.
The stream of stuff coming out of the, out of the phone, do you have to parse it to pick out stuff that you want? Is it like you get information from every sensor and even though you don't ask for it, or how does that?
Well, you can, basically, it's on like a thread, its own threads.
Okay.
If you know what I'm talking about, it's like picking up stuff on its own, processing time, and then,
Yeah, I mean, it's up to you how you format the
Right.
data, right? I mean, you could output ASCII text or whatever up to
So
the
you're
Bluetooth port. whatever.
doing all the pre-processing on the Android, and then just sending the Arduino, move
Yeah.
the motor, stupid.
right, the Android is just let's gather data from the sensors, let's send command, let's tell this motor to turn on or off.
Oh, okay, so your Android is the master.
Yeah, the Android is
Okay,
the brains
okay,
and
the
the
Arduino's.
The Arduino's
Okay,
slave.
the guy that goes forward, left.
Right, that's exactly right.
oh, so you have to add that kind of
No,
voice.
no,
Kind of dumb guy.
The only logic I put in there for, on the Android side
Is the ultrasonic.
is like the ultrasonics when it goes, okay, because it needs to be faster. It really does. So when it gets within so many centimeters, it just shuts off all communication to the other.
Oh, to the phone?
Yeah, to the
I'm not listening to you anymore, Daddy.
right. But the phone is still, going, and it just goes, no, I'm here. Let's stop.
And does the steering use just a regular servo? Or is it a bang bang?
It's full on, full off.
Oh.
It's the RC car.
Okay.
There's no like motor controllers or anything like that. It's just full on, full off.
Is it like skid steer? Or?
That's why it has to do this kind of.
Yeah, just full range.
Oh, that's
It's
steering.
full left or full right or
Either all the way
straight?
to the right or all the way to the left.
Oh.
Straight.
There was no.
And I have it
you
updating
had
every
to
100
bang,
microseconds.
bang.
So it's not what you call real time, but it's good enough to get to the car.
I mean,
Yeah, good
everybody
enough,
remember,
probably-
he touched the cone from 1,000 feet away.
That's right.
But the other design config that we had to do that I didn't mention was we had to have a kill switch. The kill switch is a separate RC toy controller that I had just lying around that wasn't, I tore it up before. But the RC part still works, so I took that out and slapped it on there, and whenever there's 5 volts to a certain pin, it shuts down the robot's movement.
So the next upgrade is going to like a Blue Note that has the Bluetooth built right into it. Take all the extra wire.
You could have won at the contest in the spring, maybe.
Yeah, but I took that home
You took it
instead.
on instead.
Well, part of the reason why I went with
The last thing
this
shows
was that, I saw some documentation on it, I don't know about this, but
Yeah.
yeah, this was, the little Bluetooth module with $5 from China.
So but that's not the Bluetooth LE, that's regular Bluetooth, right, 2.0?
Probably.
Yeah.
I don't know.
Low energy version.
Yeah, BLE is the 4.0 version, and that's so it's a little bit different configuration for the phone. You gotta run certain versions of Android on that, so that's asking.
But then you can probably go 5,000 feet without trouble because it uses less energy.
It's just so low power anyway.
So you're saying you can fly a quadcopter on the cone?
No, that's against the rules, no flying objects in there.
It isn't a flying object.
Did you, was there, I don't know, there's, I guess, several different kind of 80Ks out there. There's the Android, there's the Yo-Yo, I think it's pronounced IOIO. Why did you choose the Bluetooth approach for connecting to the phone instead of an 80K approach? Oh, yeah, I guess it's a USB.
Well,
Yeah, it's over USB.
there was a couple guys, I don't remember what their names were now, but they came to the club and they, at the same time I was developing this, they had a version that was plugged in, right?
Yeah,
And they had like a little battery pack.
right.
Well, the phone was zapping their battery pack,
Oh, over the USB or something?
right, over the USB. And it was running down their ability to actually go very far.
So it just means they wired their crap wrong.
I don't know, but I was, I have no idea.
Gotcha.
But all I know is, you know, keeping the battery separate just seemed like a better
An
idea.
easier approach or something, yeah, okay. I was kind of curious about that.
Oh, so they were trying to run the
Right.
IO off the phone?
Right.
Battery?
Right.
Oh, okay.
They were wanting to have one robot that had the battery source and the phone together so they could charge it easier.
Any other questions?
Just one comment, I think too, just because I don't have a robot to show today, so I'll burn a little time. I think it's kind of nice, the wireless approach, because I'll tell you, the way I develop software, I'd be cycling that connector a million times, plugging in, plugging out. So I'd be worried I'd be wearing out the connector on my phone, so I think it's pretty cool to go the Bluetooth
Well, it
route.
makes it easier to get the cords, you don't have to detach the phone or reattach the phone,
Yeah.
things like that. I get it. BLE would probably be the next thing I'd go for, see.
What would you do different next
VLE.
time?
Okay, different next time, I would definitely have probably a motor controller, so finally control the direction instead of doing this. To get the right direction.
You're just gonna buy the $8 car instead
No,
of the $3
no, let me point out here, because I've done the same type of RC conversion before. You could just have used your Uno to drive. You could have sent from your phone a number between 0 and 255 and let the PWM on the Android, with the Arduino, whatever they call it, library, and you control, there's nothing on an RC car that says you can't use PWM. Now, the steering, that's a different matter.
Still
That's,
just a suck-up.
unless you have one that's got proportional steering, which is more expensive, then you end up having to do the bang bang.
Well, let's see
So
what's
yours
the hack in the
isn't
servo.
servo turn for steering?
It's full on.
Yeah. So it goes bing, bing,
The,
bing.
the other thing I've seen people do is they get these cheaper RC cars and they're not able to go over grass. So if you go with this method, definitely get a 4-wheel drive, test it, make sure it goes over grass first.
Right, and the big thing there is no differential, or you change the differential oil. But if you have a differential, you're not gonna go over grass. I mean,
That would be better to have differential.
no, you have one wheel that spins.
One
Oh.
spinning and
Oh,
one stationary.
stationary.
Positive traction, whatever.
The other thing I was thinking about doing is instead of doing the flip thing, just having like a little periscope I can fit on the phone itself so it can look 360 instead of using a mechanical method to.
Just a comment on your compass. Now, I haven't played with very many phones, but I'm pretty sure the phone I have has a 3-axis compass. But it's all on how you read that compass too. That could be a problem. In other words, if you're vertical and
Well,
maybe long.
it might have been something like that, but
Anyway, that's just something to look
Yes,
into. It doesn't have a 3-axis.
It's the math from the third axis to modify the other two readings to make them correct.
all I know is when it was going around the corners, it was throwing it off quite a bit.
Yeah, it probably just didn't have the math in it for the third axis to compensate, because that's how the Z compass gets used to compensate the. But it's a pain in the ass. It's probably easier just to lay it flat.
Seemed to work.
Instead of trying to do the code.
Yeah, it's,
The other issue was anytime we get around rebar, it's too far down So I need a bigger base that's able to bring the phone up higher.
Yeah.
Otherwise, it reads that rebar and throws the compass off that way. And then it does a spiral of death. Circle back.
Magnetic black hole or something.
There's something in Paul's yard, which we're liable to end up there again, that's very evil to magnetics.
Yeah.
Over by
It's
the
all
tree.
over Texas.
Kind of guides you toward the tree.
That's the big
black
earth
hole.
magnet we buried underneath
Oh.
the ground for the first
We
outdoor
suspected
competition.
there was a
Look right.
submarine off the shore too, because some cars seem to really go for the water.
That was it.
Any more questions?
Thank you, Brock.
Yeah.